73 million years ago, in the icy expanse of what we now call the Arctic, a remarkable chapter of avian history was unfolding. Long before polar bears and snow owls, birds were nesting in these frigid realms, coexisting with dinosaurs in a world both alien and familiar. In this stark, seasonal wilderness, life did not retreat, it adapted. Amid the howls of ancient predators and the rustle of Cretaceous forests, nests were built, eggs were laid, and hatchlings emerged under skies veiled by the polar night. It was a land of extremes, and these birds were already finding ways to endure it. In a groundbreaking study published in Science on May 29, 2025, researchers unveiled fossil evidence that rewrites our understanding of avian history. Led by Lauren Wilson, a doctoral student at Princeton University, and Pat Druckenmiller, director of the University of Alaska Museum of the North, the team discovered over 50 bird fossils in Alaska's Prince Creek Formation. These fossils, including embryos and hatchlings, date back nearly 73 million years, making them the oldest known evidence of birds nesting in polar regions. This wasn't merely an incremental discovery, it was a leap backward in evolutionary time. These tiny bones, preserved in the ancient sediments of a long-lost ecosystem, are direct evidence that birds were breeding in the polar north during the late Cretaceous. Their presence challenges previously held assumptions about the types of ecosystems that supported such delicate, energy-demanding life. It wasn't just warmth and sunlight that enabled evolution to flourish. It was resilience in the face of cold, darkness, and uncertainty. The Prince Creek Formation, a treasure trove of late Cretaceous fossils, offers a window into a time when the Arctic was a lush, green environment during the summer months, teeming with life. Despite the seasonal abundance, winters were harsh, with freezing temperatures and months of darkness. Yet these ancient birds thrived, raising their young in conditions that would challenge even modern avians. The landscape would have looked dramatically different from today. Instead of endless snow and permafrost, the region was filled with rivers meandering through dense forests of conifers, ginkgo trees, and flowering shrubs. Insects buzzed through the humid summer air, and massive herbivorous dinosaurs left deep tracks in the muddy ground. Predators like Nanoxaurus, a smaller cousin of Tyrannosaurus rex, stalked the undergrowth, while mammals, amphibians, and now birds made their lives in the margins of this polar world. This was not a barren frontier, it was an ecosystem in full bloom. And the discovery of nesting birds shows that life was not only surviving, but renewing itself season after season. These birds didn't just visit the Arctic, they were born there. The meticulous excavation process involved washing and sieving sediment to isolate tiny fossils, some less than 2 millimeters in size. These methods revealed bones so delicate they could easily be mistaken for fragments of leaves or twigs. Yet upon close examination, they told stories stretching back tens of millions of years. Among the discoveries were bones from extinct groups like Ichthyornithers, resembling toothed seagulls, and Hesperornithers, foot-propelled diving birds with teeth. These birds would have ruled the skies and rivers of the Cretaceous North, chasing fish and nesting along icy banks. Additionally, fossils from toothless birds similar to modern ducks suggest a close relation to today's bird species, indicating that these ancient avians were already exhibiting advanced behaviors like nesting in polar regions. Even more striking was the presence of embryos and very young hatchlings. These weren't bones of travelers that died far from home. They were the earliest stages of life itself, preserved in stone. That level of preservation, in such a remote and harsh region, speaks volumes not only about the environment, but about the persistence of life within it. Some of the bones even retained growth marks, showing they belonged to birds still developing when they perished, likely within the safety of their nests. This discovery pushes back the record of polar bird nesting by over 25 million years, predating the previous oldest known polar bird nesting site. a 46.5 million-year-old penguin colony in Antarctica. It suggests that birds were integral components of Arctic ecosystems during the age of dinosaurs, challenging the perception of high-latitude avian communities as a recent phenomenon. And it raises important evolutionary questions. Were these birds warm-blooded like modern avians? Did they have feathers thick enough to insulate them from sub-zero temperatures? Did they migrate during the harshest part of the year, or did they remain and endure the endless night? The fossils don't yet provide clear answers, but their mere presence suggests behavioral complexity. These birds were capable of exploiting extreme niches. Their ability to raise offspring in the far north suggests that nesting behaviors, thermoregulation, and possibly migratory patterns were already established tens of millions of years before the mass extinction that ended the dinosaur era. The presence of embryos and hatchlings indicates that these birds were not merely passing through, but were breeding in the Arctic. Whether they migrated south for the winter or adapted to endure the harsh conditions remains unclear. However, their existence demonstrates a remarkable adaptability and resilience, traits that have allowed birds to survive and thrive through mass extinctions and climate shifts. Their survival strategies may have been remarkably similar to those of modern birds that nest in northern environments today. Some modern species like Arctic terns and snow buntings show exceptional physiological adaptations to cold, along with behaviors like seasonal molting, compact nesting, and high parental investment. These Cretaceous birds may have evolved comparable traits millions of years earlier. And while we may never observe their behavior directly, each fossil recovered provides a new clue, like a flash-frozen moment from a vanished world. This discovery not only enriches our understanding of avian evolution, but also highlights the dynamic and complex ecosystems of the Cretaceous Arctic. It serves as a testament to the enduring spirit of life, persisting and adapting in the face of adversity. The Prince Creek birds are more than ancient curiosities, they are evolutionary touchstones. They tell us that even in the coldest corners of the earth, life has always found a way to persist. Their fossilized bones whisper the story of how today's birds, from sparrows to eagles, may have inherited more than wings from their ancestors. They inherited the will to survive anywhere. And perhaps most profound is what their presence tells us about extinction. Not just who disappeared, but who remained. These birds, once neighbors to Triceratops and Tyrannosaurus, would give rise to the only dinosaurs that made it through the end of the Cretaceous. Their descendants would inherit the skies. As we continue to unearth the secrets of our planet's past, each fossil tells a story of survival, adaptation, and evolution. What other tales lie buried, waiting to reshape our understanding of life's history? Subscribe to our channel to stay updated on the latest discoveries that illuminate the ancient world.